So how do you get a connection between the power company's distribution neutral and the customer facility? Well, that has to do with how power is transferred to clients at a transformer. And here we have an image of the utilities neutral. Our concern is not about the phase wires, any of the phasing. We show that the bushing at the top connecting to a high voltage line, but our concern will be on the utilities neutral. We show that in green on the left. So it ties to the tank, and it doesn't matter whether this is a pole mount transformer or pad mount transformer. It's exactly the same thing. Even though they look a little different, it's connected just like this. So the utilities neutral lands on a lug on the tank, the metallic tank, and then ties to a ground rod down at the base of the pole. Another ground strap is connected, or utility ground is connected between the tank and the customer's secondary neutral bushing, listed as the XO bushing. So that ties to the customer's neutral terminal and then on to the neutral into the facility or house. This is the typical scenario, whether it's pad mount or pole mount. Here's the currents that result when we have a gradient, again shown from right to left. So current flow on the utilities neutral can flow to the tank and the grounding system. It also flows to the connection to the neutral strap. So the utilities customer, served by this XO bushing, has a connection between the tank and the neutral. And now, if in our story here, there's another customer as well, served to the left. That was our rectifier stand in this story. Current can follow on the customer number 2, neutral, down to that rectifier stand, and then with its consequential actions. On this slide, we see the typical scenario with a decoupler added to the system for the purpose of separating a customer who typically has a CP system, such as a pipeline company, from the power company and their grounded system, such that CP current doesn't also flow to the grounded utility system. So if that's true, our scenario here is we have a decoupler installed between the grounded utility tank, which ties to the utility neutral system, and that's the positive connection, and the decoupler negative connection goes typically to the facility that has cathodic protection, which is the secondary neutral. The secondary neutral goes into the facility, ties to the grounded structures, ties to the CP system, and that's why you typically have this problem. So while this is the typical installation for a decoupler, our story here has a twist, so we're going to find out whether decoupling is actually effective or not. Back to our story here with 2 customers. We have 2 customer neutrals. You also have power conductors that I'm not showing here, serving, in this case, the house on the right and the rectifier stand on the left. If you add a decoupler, what have we done here? Can you serve both customers with a single decoupler and accomplish something useful in this case? Well, here's what would result. Normally, most situations, adding a decoupler to separate a cathodically protected facility would be effective. In this case, though, we have a strange situation of a voltage gradient affecting this residence and this rectifier facility, and we have 2 customers, and the orientation of the neutrals facilitates current flow. So pickup at the house on the right is shown with current flow in blue here, following the neutral back to the transformer, and then further following the second neutral to the rectifier stand. The decoupler has stopped interaction between the utilities distribution neutral and both customers, but it cannot stop both customers from interacting with each other. So as shown in the blue, that current continues to flow even though the decoupler has stopped the interaction between the utility pickup current, shown in red, and the customer's neutrals that have the blue current shown. Shown a little differently in a plan view, the red current, the red indication shown on pickup on the utility system is separated from the customers, the set of two customers in this case, shown in blue. So there still can be pickup at a house, current flow down its neutral, current flow from the bond of the transformer down to the rectifier cabinet and the phone company bond. And the decoupler, if added, it wasn't added in this case, if it were present, it could separate everything that's shown in red, everything shown in blue. But it can't ultimately solve this problem because two customers are served off of the same transformer.